Hi there, welcome to this video on making maps for bushwalking and canyoning purposes. My name is Tom Brennan and I'm a Sydney-based bushwalker and canyoner. I run several websites, bushwalkingnewsouthwales.com for bushwalking, ausultimate.com for canyoning and personal interest, and maps.ausultimate.com for planning and sharing bushwalking routes. I've been bushwalking and canyoning for about 25 years. And of those 25 years, I've spent over 20 of them exploring canyons around the Blue Mountains and doing exploratory bushwalking. I do both private trips and also walk with the Sydney Bushwalkers, or SBW Bushwalking Club. The main reason for this video is to share some of the information I've gathered around finding routes and creating maps for finding passes and other purposes. This is an introductory session on using a free piece of GIS software. GIS stands for Geographical Information Systems, called QGIS. We'll also be using free geospatial data from New South Wales Spatial Services, though you can get similar data in some parts of other states, but not all. If you're keen to go further than this introduction, there's a lot of information on my maps website, maps.ausultimate.com/wiki. I'll put the link down in the description below. First things first, you will need to download and install QGIS. So go and visit qgis.org, the link's in the description below, and click download. And you can skip the next bit for now. QGIS is available for Windows, Mac OS and Linux. I'm running on version 3.34. The latest versions increase by a couple of points every 3 months, and the long-term version changes once a year. Unless you're at the cutting edge, which we're not, any version should do. If you're not sure, just get the latest long-term version. It's a large download and install, so if you don't have this yet, just pause the video and come back when you're done. The data we'll be using is based on LiDAR data. Essentially, LiDAR involves flying over an area, shooting beams of light that bounce back and get collected. Based on the time they take to return, we can calculate how far they travelled, allowing us to create very accurate height models, much more accurate than older methods that used aerial photographs and stereogrammetry. This enables us to make much more accurate maps than what's currently available. LiDAR data is processed into digital elevation models, commonly referred to as DEMs or DEMs. Raw LiDAR data is huge in size and very slow to process. So while you can download and process LiDAR data yourself, it's a lot easier to work with DEM data that's already been processed for you. In order to access the LiDAR and DEM data, let's start by looking at something called ELVIS. ELVIS, which stands for Elevation and Depth for Data for Australia. You can access it at elevation.fsdf.org.au. The link is in the description below. This is where you can find any DEM data that's available for free anywhere in Australia. The map shows where any data is available. The blue colour is for elevation data and the orange colour for depth data. Generally speaking, the darker the colour, the more detailed the resolution of the data. If there's no colour, then there's no data available. New South Wales has got 100% coverage of LiDAR-derived DEMs at a minimum resolution of 5 metres. The resolution is important. Smaller numbers mean higher resolution and more accurate maps. Older maps aren't based on LiDAR, but the underlying data is probably equivalent to around 5 to 10 metre resolution. So for more accurate maps than current ones, we're particularly interested in resolution numbers below about 2 metres. Now, in terms of other states, Tasmania actually has full DEM coverage to 2 metres, but some of this is interpolated and not actually generated from LiDAR. That said, Tasmania does have a reasonable area of the state covered by 1 metre LiDAR DEMs, but New South Wales generally has more detailed coverage, 2 metres or 1 metre, in the areas that bushwalkers are interested in. Victoria's got some coverage, but only to 10 metres minimum, though there's some areas of interest down to 1 metre. Queensland's got decent coverage near the coast to 1 metre and in some areas 50 centimetres, but patchy coverage once you get away from the coast. We're going to be focused on New South Wales data, but the processes here should work with any DEM data. To get data, zoom into your area of interest on the map. We're going to be zooming into an area north of Sydney around the Colo River. If you click Order Data, click Draw, and then select the top and bottom points of your map and click Search. And it will show you the available data. You can see that there's both digital elevation models and point clouds. The point clouds is the raw LiDAR data. Digital elevation models is the processed LiDAR data. For the purposes of this workshop, we're interested in the digital elevation models rather than the point clouds. So you can select the relevant data, for example, by clicking Select All. And then to order it, you just need to enter an industry. I usually put recreation, but you can choose any one you like, and enter your email address. Once you've done all that, you can click Order. Within 5 to 10 minutes or so, you should receive an email with a link for you to download your data. Now, for the purposes of this video, I've already downloaded the datasets to use from ELVIS, so I'd suggest that you use them. So pause the video and head to the link in the description below, which is ausultimate.com/download/basicmappingworkshop2024.zip. I'm going to unzip this to somewhere convenient, like your desktop. Inside, you'll find 6 files. The one from ELVIS is called data_842747, which is exactly as I received it from ELVIS. So you'll need to navigate into the folders. So New South Wales Government Spatial Services, DEM, 2 metre, until you get to the actual files. The TIFF files are the ones that we're interested in. So you want to drag these out onto somewhere convenient, like your desktop. All right, once you've extracted the files, open up QGIS, which you installed a little bit earlier. Before you do anything else, make sure you have the Layers panel visible on the left-hand side of the screen. That's this one here. If it's not there, you can go to View Panels Layers to enable it. The processing toolbox should also be available on the right-hand side, which is not for me. But you can enable this by going to View Panels Processing Toolbox, and now we can see that. This toolbox contains many of the tools we'll use, probably more in later sessions. Alright, so now we want to load and merge data. So head back to your desktop and grab those 4 DEM files that we just extracted from the zip and drag them into QGIS. And you can click OK through this. Alright, you should now see 4 layers representing the different tiles. Each of these tiles is a digital elevation model, DEM, with dark areas, like here, representing lower elevations like rivers, and light areas, like here, representing high areas like peaks and ridges. So our first task is to merge these 4 tiles into one seamless layer. To do this, go to Raster, then Miscellaneous, and then Merge. So in the tool that appears, click on the 3 dots here under Input Layers, click Select All, and back to this, this screen. There's nothing else that you need to do here, so you can just click Run. Hopefully that runs fairly quickly for you. So after merging, you'll see a new layer called Merged in the Layers panel. So we can now remove the original 4 layers as they're no longer needed. Up to you. So I'm going to select them all, right click and remove. Okay. So now we're going to create some contours. For this, go to Raster, Extraction and Contour. Most of these tools you can also get from the processing toolbox on the right, but there are quite a lot of different tools that pull out contours, and going via the top menu is the easiest way of getting the standard one. So we're going to choose the merge layer as our input layer, which for me is already selected. We're going to set the interval between contour lines to 5 meters. Nothing else that we need to change, so click Run. Alright, so now you should see a set of 5 meter contours on your screen. If we zoom in, you can see that the contours show some quite steep areas down near the river, and there's some gentler slopes up on the tops. Now you can turn off the merge DEM layer if you want to see the contours a little bit more clearly, because the dark background makes it a little bit tricky to see. So you can do that just by unchecking the box next to the merge layer. So let's style these contours a bit. As you can see, mine have appeared as a, hard to tell what color that is, it's a sort of a yellowy olive brown maybe. And you'll get some kind of random color in your case, whether it's, garish green, blue, red. To change that, you can double click the contour layer. On the left hand side you'll see the symbology tab, which for me is already selected, and here you can see the color, and so you can change the color. Now in my case I like a sort of a reddish brown sort of color for my contours, so we'll get something like that. You can just drag these sliders around to get something that you're happy with, and then hit OK. And then hit OK out here. Alright, now I've also provided a style file in the zip package, and you can actually apply that directly to this layer. So to do that, what we can do is, again, double click the contours layer, again symbology. Down the bottom here you can see this style drop down box. So click Load Style. Click to browse. Now you'll need to navigate to wherever you saved that file, that zip file before. And in my case, we want to load this contours 5 meter scale file. Click that. Open, load style, and OK. Now you'll notice a few things. So the contours now have labels, and you can also see that there's thinner contours representing the 5 meter contour intervals, whereas there's thicker contours representing the 50 and 100 meter contour intervals. Also, if you zoom out, and it's not necessarily going to be as easy to tell, but as we zoom right out, the 5 meter contours actually disappear and only the 50 meter contours are visible. Zooming in a little bit, it's now got 10 meter contours, but the intervening 5 meter contours have disappeared. So this demonstrates how you can use style files in QGIS to not only style, but also adjust the display of things as you zoom in or out. Alright, the next thing we're going to look at is slopes. This is probably the most interesting part for exploratory bushwalking and pathfinding. So we want to create a slope file from the DEM. For that, go to Raster, Analysis and slope. Select the merge layer again. The default settings for this are fine, so you can just click run. Alright, so the slope map applies a default style. You can see on the ridges it's dark, while the steep slopes near the river are bright white, indicating steep areas. The dark areas up in here represent low slopes, which are easier to walk on. The right areas are steep and probably, when they're fully white, unclimbable. So rather than using this default style, we'll modify it. So double click the slope layer. Now, since it's a raster layer, you'll see different symbology options. So in this case, we're going to change the symbology from single band grey to single band pseudo color, and adjust the interpolation to discrete. Now we're going to select the color ramp. And in my case, I'm going to go to all color ramps, and unfortunately this is going to disappear off the bottom of the screen, but the one we're interested in is the YLORRD one right at the very bottom. Alright, so we've got 5 classes, and I'm going to click classify, which it looks like it's already done. Now, and I'm going to hit apply just so we can see that in the background. Alright, so from here we can actually adjust the values that these things, the different bands go through. So I'm going to set the top band is currently set to everything above a certain height. This one here I'm going to set to 70, 60, 50, and the yellow to 40. And I'm going to hit OK. So now you can see the contours with this color scale. So the dark red areas representing the cliffs, orange areas, minor cliffs, yellow at the moment is probably something that you can walk through, an area less than 40 degrees. Now, I didn't do a particularly good job on this style file. It was just a sort of a quick and dirty one. But again, I've provided an already packaged style file. So to improve that, let's go and load it. So double click again, down to the bottom, style, load style. 3 dots, and the one we're interested in here is called slope cliff line. So I'm going to open that, load style. All right, now the other thing I'm just going to do quickly is I'm going to drag the contours layer above the slope layer. So we'll just pop that up there because it makes more sense to have the contours on top of the slope than the other way around. All right, so I've been using this approach, so this kind of coloring, or for walking around the Blue Mountains for the last 4 years or so to look for passes and routes. White represents slopes less than 40 degrees, so anything white is generally easy to walk through, though by easy I mean passable for experienced off-track bushwalkers. It can still be quite steep, loose and challenging. All it means is that you're probably not rock climbing. If we zoom in, small areas of yellow are usually passable, so things like this, often with some scrambling. Large solid yellow areas, like around here, often hide small cliff lines, so may prove difficult. Essentially, when you're working with a 2-meter DEM, that can really hide 2-meter cliff lines quite easily, and they don't always break. Orangey areas are sometimes navigable, sometimes not. Dark orange or red areas usually represent solid cliffs and most of the time impassable. So the reason we're looking at this specific area is that on a walk with my bushwalking club, we attempted to find a pass down to the Colo, pass 30C, described as a steep scrambling pass requiring ropes. Now if you go to the workshop files and find the one called pass30c.gpkg, this one here, we can drag that into QGIS and drop it. Now, what I'm going to do is just style this a little bit. So double click on it. I'm going to make it wider from 0.26 to 0.6. And I'm going to change the color so it stands out a bit more. So I'll make it a fairly bright green. Alright, so on the left-hand side here, you can now see the original pass 30C, which likely went through these cliff bands around here. It's probably the steepest part. On the right here, you can see the path that we took down to the Colo. So by following this map, we decided to essentially meander first down the main part of the ridge, and then traverse across the slope through these patches of light yellow, and eventually just a little bit of easy scrambling down here near the river. Most of the walking through the white and yellow areas. Essentially it turned out to be an easy walk down pass with a little bit of scrambling achievable by any competent off-track walker. So this level of coloration is quite useful for identifying potential passes. However, it won't reveal every pass, especially those that go under cliff lines or through tight slots. Also, these colours are calibrated for the Central Blue Mountains, where the nature of the rock is that most smaller cliff lines have got regular breaks in them. If you're walking in other areas, you'll need to see what works. So for example, in areas like Moreton National Park or up in the Bylong Labyrinth in the north of Wollamai National Park, you often encounter small continuous cliff lines that don't have visible breaks. Likewise, if you're in rock types other than sandstone, you will likely need to recalibrate. But in the Central Blue Mountains, this style is very useful for picking out potential passes. Definitely makes a useful map for identifying routes during exploratory canyoning, for example, in areas like the Kurunguba. Alright, we'll wrap up this first session here. However, don't shut down QGIS. We'll pick up using everything we've done so far next session when we look at streams and watercourses. Thanks for watching and see you next time.